Well, grade 9s, I hope things are going all right for you. I hope you've finished the plotting, which should have taken you close to about 30 seconds or so, maybe a little bit more than that. And the distance calculations, that's a little bit more busy work. It's not difficult math, it's just the busy work that's behind it all. As well as the midpoints, you should have had a little bit of busy work for that one, but again, not that difficult. So now, when I ask you to find the slope of a line between 2 points, or the line that connects 2 points, so I'll title this one Calculating Slope. Okay? Slope, first and foremost, is designated with the little letter M. That letter means slope. Okay? Don't ever forget that, because you're going to use that, oh boy, lots in your mathematics from here until you graduate high school. So little m's represents slope. Don't ask me why. I didn't invent it. I didn't create it. That's just the way it is. Okay? But slope, another way of thinking of the word slope is how steep something is. How steep something is. It's a measure of that. So you can think of comparing something with a slope of equal to 2 and something that has a slope that's equal to 5. Which one's more steep? Well, the m equals 5 is obviously steeper or has more slope. The same thing with negatives. Whether it's negative or positive doesn't mean it's more steep or less steep. What it tells you is direction. So positive I think of as going uphill, negative as going downhill. Okay, so if you're going uphill and it's a steepness of 5, your hill that you're going up, and then on your way home you're going to go down that same hill, well, it's the same steepness, it's just negative. You're going downhill. Okay, so negatives and positives, they just kind of tell you direction that you're going. Okay, so let's plot some points here, and we'll see how this works out on how it's done. And this is used in a lot of industry like carpentry and stuff like that. They'll use it to figure out how stairs work, rafters. You'll hear sometime in your life, you'll hear somebody say, oh, that roof has a pitch of 412. Well, right away you'll see where that comes from. So, slope, again, like I said, is denoted by the little letter m, and I'm just going to give you the formula here. The slope equals y2 minus y1 divided by x2 subtract x1. And some people use this saying, rise over run. Okay? Because it's the change, rise over run. And again, some people will also go like this. They'll use a little triangle. The letter for that is actually called delta, change in, and delta x. So that actually says the change in y over the change in x. Change in y values over the change in your x values. But this formula is the big daddy. That's the one you want to remember. So, for example, let's go and plot a couple points here. Let's plot point A, we'll say 2, 1, and B, we'll say is 4, 7. Okay, let's look at this and see how steep this is. So there's x, there's y. When I plot A, 1, 2, and I go up 1, there's point A. And I plot B at 3, 4, 2, 3, 4, 5, 6, 7. So 4, 7. There's B. So the line joining them is what we're trying to find the steepness of. Now that's a pretty steep line, but let's see how steep that is. It's not vertical, so it's obviously something. But again, what's the first thing I'm going to tell you to do? Always label points x1, y1, x2, y2. Always, always, always. Okay? You should always label your points x1, y1, x2, y2. So, let's go back to it. And let's say x1, y1, x2, y2. If you don't do that, grade 9s, you will have troubles in this unit. So just take my advice and do it. So, calculating the slope. The slope from A to B is the rise, the change in your y value, over the change in your x value. So again, let's go back here. If you look here, the rise of this line goes all the way from 7 to 1. 7 minus 1 is 6. And the run of it goes from 4 to 1. 4 minus 1 is 3. Okay? So you've got a rise over a run. So the slope from A to B is equal to y2 is 7, subtract y1, over x2 is 4, subtract x1 is 2. You have a slope of AB with a magnitude of 6 divided by 2. Slope of AB is equal to 3. Okay? Now, remember, it's a rise over a run. So it's pretty easy for me to say 3 over 1 if I want. Okay, reduce that. And what that says is for every 3 I rise, and I'm going to plot it right on my little graph here in green. For every 3 I rise, 1, 2, 3, I run 1 and end up on the same graph. So for every 3 I rise, I move over 1 and I end up on the same graph. So I could keep going with that and I would end up having a straight line at all times. So let's do another example. If I said, calculate the slope of the line joining the points -4, 6, we'll call this P, and Q, 5, -3. Let's do this. Well, I'm going to label my points x1, y1, x2, y2, just like so. And my slope of P to Q is equal to y2 minus y1 over x2 subtract x1. Okay, when I plot my points into there, I get y2 is -3. Subtract y1 is 6. Divided by 5, which is x2. Subtract a -4. Well, minus a -4 again, grade 9s, it becomes a +4. Okay, so the slope from P to Q is equal to -3 minus 6 is a -9. Divided by 5 plus 4 is a 9. So the slope of the line joining P to Q is equal to -1. So now, what does that tell us? Well, if you think back to the last example, which way was our line going? I would have called line AB going uphill. AB. That's what I call going uphill. So our slope was a +2. +2. And positive going uphill. And I said if it's negative, that just means it's going a different direction. So I'm going to plot this point PQ and see if it's going downhill, or what I would call downhill. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So there's P. And Q, 1, 2, 3, 4, 5. 1, 2, 3. There's point Q. Well, when I look at this line, that's what I call going downhill. So from P to Q, that's the direction I call downhill. So any line that is going downhill has a negative slope, and any line going uphill will have a positive slope. Now, what they equal really is kind of up to how steep they are. The direction is the sign, okay? So maybe let's write that down. Any slope you get that's greater than 1, or greater than 0, sorry, greater than 0 is rising to the right on the plane, okay? I always think of it as going uphill. Any slope that's less than 0 is falling to the right. Okay, so going downhill. Okay, so negative, this is positive. These are negative numbers, right? Less than 0. If it's equal to 0, let's think about that. If you have a 0 steepness, grade 9s, what kind of line is that? Well, if you said that it's a horizontal or a flat line, that's exactly right. Okay? It has no steepness. It's flat. Okay? Now, there's one other one. And if you thought, yep, it's that one that's going straight up and down, you're right. That's vertical. But let's jump over what it's equal to. What could a vertical line be equal to? Well, it's so steep that we can't even describe it, or we can't define it, so we actually say it's undefined, because we can't define it. So if you get a slope of a vertical line, your answer should be undefined. And we're going to do examples of horizontal and vertical right now so you can see the two of them, okay? And what they look like for answers. So we'll do a horizontal one first. We'll just pick point A, we'll say 4, 3, and B, 5, 3, okay? Let's change that to a 6, 3. We'll give it some separation. 6, 3, okay? If I plot this real quick just so we can see this. 1, 2, 3, 4, 1, 2, 3. There's A. And B, 6, 3. There's B. So it's a horizontal line. Again, x1, y1, x2, y2. Nothing different. And I put this into the slope formula. Slope of AB. And we can see that it's a horizontal line, so we should end up with a slope of 0. Well, y2 minus y1 is 3 subtract 3. Divided by x2 subtract x1, 6 minus 4. The slope of AB is equal to 0 divided by 2. Well, 0 divided by 2, we should all have 0 for an answer. Hence, horizontal line. Perfect. Okay. Now, let's do a vertical line. Let's see if I can squeeze this in here. Let's call it C. Let's go with negative 3, 5. And D, negative 3. Give me a second here. I'm losing stuff. Negative 3, 7. Okay, it looks like I'm going to be able to squeeze it in here. Okay, and I hope you noticed with a horizontal line, what was the same? Your y values. Okay, so that's saying it's on the line y equals 3. For a vertical line, or an undefined slope, I hope you see what's the same. Your x values. So if I go over to negative 3, 1, 2, 3, and up to 5, there's C. And then negative 3 up to 7 for D. So there's a vertical line, straight up and down. Well, let's try this out. x1, y1, x2, y2. If I plug this in, the slope from C to D. y2 is 7. Minus 5 is y1. Divided by negative 3 is my x2. Minus a minus 3 becomes a plus 3 for my x1. So the slope from C to D is equal to 2 divided by negative 3 plus 3 is 0. Now, lots of people in grade 9 make the mistake of saying 2 divided by 0 is 0. But it's impossible to divide by 0. You should know that by now, that you can never divide by 0. It's impossible. So what we say when we're talking about slopes is it's undefined. That tells you it's a vertical line. So if you ever see any slope where it's divided by 0, you know that you're talking about a vertical line. All right? Okay. So I think that you should be able to do assignment D with those. Okay? And that's all it is. Rise over run, rise over run, rise over run. So you're changing your y divided by your change in your x.